Hello again. We are excited to welcome our next keynote speaker, Dr. Anders Sandberg, who is a senior research fellow at the University of Oxford's Future of Humanity Institute. His keynote is titled, "What is the Potential Size of the Future?" Please welcome Dr. Anders Sandberg.
I'm not going to speak about how we're going to be living in a Star Trek future where everything works perfectly well, except when the plot desires something to malfunction. We should be aware that I'm speaking about a real future, a potentially real future where stuff is going to go wrong in interesting and sometimes horrifying ways. Yet, I think I can give you a very positive future. I would wish to demonstrate that we can actually encounter an enormously large future, a potentially very good future. And this gives us a very strong reason to actually aim for surviving. Okay, I want to mention a hero. So 59 years ago to this day, the world was literally saved by Vasily Arkhipov. So this was right in the middle of a Cuban Missile Crisis. There was a US blockade of Cuba. Soviet submarines were trying to evade it. They were on international water, but the US forces were trying to get them up to the surface so they could identify themselves. One particular submarine, B-59, was incommunicado. They had not been talking to Moscow, and the Americans were then dropping depth charges to force them up so they could identify themselves. Inside the submarine, things were getting stuffy. The air conditioning system was failing, and they had very good reason to believe that war could have broken out. Also, unbeknownst to the US forces, they had a nuclear torpedo at 10 kilotons of yield, and they were given permission by Moscow to launch it if needed. But they needed an unanimous decision to fire it. The captain was convinced that war had broken out and said that it was better to go out in a blaze of glory than go down to the seafloor, and the political officer agreed. However, Vasily Arkhipov, who was a flotilla commodore and happened to be on this particular submarine, this was just random chance, disagreed. He had some experience from another submarine disaster involving a nuclear submarine some years earlier and decided, no, I'm not going to give that an order. And eventually they came up to the surface and realized, yeah, there was no war yet. Had they fired that nuke, they would probably have triggered the Third World War. Indeed, President Kennedy afterwards said, yeah, it was probably about a third chance that we would have got into a nuclear war over that. The Cuban Missile Crisis came about because of random chance. Misunderstandings of diplomatic nature about how the Russians would react to mid-distance missiles in Turkey, escalating for very human reasons, leading to a situation where literally one person could have decided the fate of the world. There was many other close calls during the same days 59 years ago. Humanity risked it all, and now I'm going to talk about what we risked and what Arkhipov helped save. So I'm interested in thinking about how big the future is. And one obvious question is, how do you measure that? Do we measure it in time? Or do we measure it in places we can go? Or wealth? After all, we could get a lot of gold in the future. Maybe that is what we should be accumulating. Or maybe it's stock market prices. How high can stock market prices ever go inside the cosmos? Or maybe we should measure it in lives or happiness, or information, or whatever philosophers would call moral goods. And then, of course, the philosophers would disagree a bit about what the good is. But another important question is, are we early or are we late? What is there to hope for? Some people would say, yeah, actually, why think about how big the future is? Shouldn't we be content with what we are? Shouldn't we be content with the current situation? And I think, as the previous somewhat doomsday-like slides have shown, actually, we shouldn't. We're living in a world where a press of a button can destroy everything we lived for and most of our loved ones. We're living in a world where a pandemic can really mess up everything. And we certainly want more. We want more justice. We want more insight. We want more wisdom. There are many things we might want to get. Once upon a time, people didn't really think there was much more to get. If you read the Greek philosophers, it's interesting to notice that they assume the universe is basically eternal and unchanging. Sure, kingdoms come and go. There is various historical events, but eventually they get forgotten. Humanity endures. Maybe the gods sometimes cause a deluge or destroy the world, but a new one is going to come into its place, and it's going to be basically the same. What happened during the scientific revolution was that people started noticing that there is evidence around us that the world is much older than the Bible says, much older than most of our history and myths. The rocks themselves are speaking about enormous ages in the past that were not just terrifyingly old and without people, but also very different. Different kinds of creatures existed and went extinct. That was the first seed to the realization that humanity could go extinct. But even more important, it showed that there can be history without humans as actors. And as science continued and started looking outwards into the universe and started measuring details of atoms, it became clear that this history was terrifyingly deep. It was not just millions of years of sedimentary rock. It was literally billions of years back to the formation of Earth. And before that, 13.7 billion years ago, a Big Bang that created the universe. This led to this perspective that humanity is rather recent arrivals. But you can also use this science to start looking forward. We can make predictions about rock erosion rate. We can start thinking about the Grand Canyon and what is it going to be like in a million years, because the erosion is going to keep on continuing, widening and softening it. We can look at how stars evolve and figure out that, our own sun is going to become a red giant in 5.2 billion years. We can look at the expansion of the universe and actually model quite well where it's going. So in astrophysics, this is sometimes called Physicaleschatology, a name coined by Martin Rees, the Astronomer Royal of England, because eschatology in religion is looking into revelation, the meaning of it all, the apocalypse, the final things. And astrophysics actually allows us to think a bit about the final things, about planets, stars, galaxies, and the universe itself. We're right now living in the stelliferous era where there are stars. It began probably a few million years after the Big Bang, and is going to last for about 10 trillion years. There are red dwarf stars shining right now that are still going to be sputtering out in 10 trillion years. They're very long-lived. They're the little Volkswagen Beetles of astronomy. But the interesting thing is we can talk about eras beyond that. We understand the physics of neutron stars and white dwarf stars and can describe even the universe after the stars have gone out. And it turns out that there are events that can be predicted fairly solidly far into that era. We can discuss how galaxies eventually evaporate because of gravitational interaction. And then beyond that really remote era, there are hints that maybe matter isn't stable and protons eventually decay somewhere north of 10 to the power of 36 years. An unimaginably large number, and we have never ever seen a proton actually decay, so it might be that they decay even slower. Beyond that era, there is an era dominated by black holes slowly evaporating, and beyond that, the actual ultimate darkness. But we're talking about something literally a Google years in the future. There is plenty of time before even the current bright stars start going out. So my big project here is thinking about the role of humans in all of this. Because we can tell a grand story about the evolution of nature, but we humans are a part of nature that is unruly. We change things. And my project academically is to rigorously review and outline the limits to what humanity and intelligent life can do in the long-term future, and how good these possibilities are according to different value systems. Now, this is a bold attempt because human action, our culture, are unpredictable. Some of it is due to luck. Some of it is due to people having brilliant insights that cannot be predicted beforehand, because if you know you're going to have that brilliant insight, you already got it. But what we can do is we can use science to place conservative upper bounds on what's possible based on known physics, and we can also use exploratory engineering to show lower bounds on what's in principle achievable. Exploratory engineering is when you do engineering, you literally make blueprints or mathematical models of things that you cannot build yet. But if you had any amount of diamond blocks, or if you could build things of a particular kind, you can analyze what their properties would be. You can analyze what is possible according to known laws of physics and engineering. And this might not be a good solution to the actual problem. Future people are going to laugh at our very crude ideas, just as we're kind of gently laughing at Victorians thinking about sending people to the moon using a giant cannon. Yet, you can use that to put some lower bounds on what's possible. And I think if you do this analysis, we have very good reasons to think that the future could be far richer, happier, more secure and sustainable than we normally imagine. I'm just going to run through a lot of things that are going to sound awfully utopian without terribly much justification, because unfortunately I don't have the time to fill whiteboards and with interesting equations and data. But generally it looks like getting very high standards of sustainable material wealth is totally doable physically. We already know roughly how societies as rich as ours work, and we actually have pretty good ideas about what it would take to actually make production of object, services, and other forms of lifestyle in a sustainable way. We know basically that a lot of these things we take for granted can be done in a sustainable way. We're not doing it yet. It's too expensive, and sometimes we're a bit too uncertain, but we can get to it. The laws of physics are not saying that we have to be unsustainable. They also don't say that we have to be unhappy. If you think about the normal human variation in happiness, health, longevity, and well-being, that already shows what's possible. And we're getting closer to actually achieving that. Again, at a rate that is much too slow for many of us who's starting to get gray hairs and sometimes think that our memories are giving out. But we are getting the tools to actually reach at least currently optimal levels and probably go far beyond our evolved limits. Sorry. It also looks like this can be achieved in a sustainable way. Again, many people have a tendency to think that, yeah, living in this kind of high-tech civilization is going to wear out the planet. But it looks like we can give existence proofs that it's actually possible to do agriculture that doesn't wear out the soil, that you can actually do recycling indefinitely. It might even be possible to extend the natural lifespan of the biosphere. I mentioned earlier that the sun is going to become a red giant in a few billion years. Long before that, Earth is going to overheat unless we actually do some proper climate engineering to fix it. Obviously, we might want to fix our current climate conundrums, and they're already a big problem for our current immature civilization. But in the really long run, we might actually have a responsibility to the biosphere to not just save it from humanity, but from the sun. When we look at going further, of course, the possibilities become even more grandiose. So one can make a minimal model of setting the solar system using something like the International Space Station, which wouldn't be terribly nice. But you can build more grandiose ideas like Gerald O'Neill at NASA envisioned in the 70s, and now Jeff Bezos is hoping to make real. And it looks like then the habitable zone of the solar system would allow us for at least have about 10 trillion people in the solar system. And they would not be vulnerable to what happens to Earth's biosphere. They would be able to persist for literally billions of years. If you go to other stars, which is a very hard problem, but Breakthrough Starshot is already aiming at using laser-propelled probes within a relatively few number of decades to nearby stars, it looks like we could definitely get something on the population of the order of 10 to the 29 people. That's unimaginably far beyond our current 7.3 billion people. It also looks like it's possible to set over intergalactic distances, limited only by the expansion of the universe and how fast you can go. And that might enable populations up to 10 to the power of 38 people. And no, I cannot envision this. If every human life was a grain of fine dust, the total amount of that dust would correspond, the mass of it would actually correspond to more than the mass of the Milky Way. We can't imagine how many lives, how much happiness, how much drama, how much creativity there could be in that future. Similarly, we can look at how long we could survive. If we just avoid destroying ourselves and survive like any other mammalian species, we could be around for 1 million years. If we actually survive as long, manage to handle mass extinctions and other big events, we could be around for 1 billion years. Settling the solar system, as long as the sun is around. If we settle the Milky Way, and then at least as long as we're stars. And if we use artificial energy sources, probably the limit is the stability of matter itself. In these processes, information has been going on, and I've been spending a lot of time, because I'm a computer nerd, looking at how much computation is possible. And a lower limit in something like a Google 10 to the power of 100 computations, and likely far more, because quantum computers and reversible computers can do more. I can continue analyzing and talking about these grandiose schemes, encasing stars into Dyson spheres to gather their energy and perform computations. It turns out that we can use similar mega-scale engineering to literally move stars. You can literally move a galaxy by putting aluminium foil around stars in clever ways to use their starlight to very gently nudge them into trajectories so they interact with each other and do gravity assists. You can set that up so you make more complicated free body interactions that allow you to literally steer all the stars in a galaxy. And you can fling some of them out, either to propel the galaxy forward like a gigantic rocket, or send them over to other galaxies where you want to gather together more mass and energy against the expansion of the universe. This is the ultimate swarm robotics problem, with literally trillions of little swarm robots that are entire solar systems. Why would you even want to do that? Well, it might be a matter of resources. Notice that I'm not talking about the details of these super civilizations. What are they doing? Are they making some advanced version of World of Warcraft, or watching the advanced version of Game of Thrones? Or are they creating art, or having wars? Or what are they doing? I can't tell, because that is up to them. What I can analyze scientifically is the limits of matter, energy, and information. And that allows us to understand something interesting about the role of life in the universe. Because life is potentially a phase transition of matter. Dead matter usually just sits there, slowly growing in entropy. But life converts dead matter into self-replicating systems that take in energy and excrete entropy and maintain themselves, reproduce, evolve, and create new complexity that didn't exist before. And now it turns out that intelligent life might be even more unique. After all, Earth is the only planet that has reverse meteors. Chemicals get gathered together by this weird biospheric stuff on top of it, put into steel cans, and launch off into space. We are the only planet that does that. And that only happens because there is life here, an intelligent life that thinks that rockets are neat and maybe something we should be doing. We do a lot of other improbable things. Meanwhile, the natural universe, in some sense, does the probable things. The picture to the right is a simulation of a very, very large part of the universe. And you can see that it's like a foam. These gigantic voids are literally millions of light years across and fairly empty of galaxies which form this complicated filament. It's said that there is an end of greatness scale, 200 megaparsecs wide, literally many millions of light years. Beyond that, it's basically all the same. It seems like we can actually reorganize matter on a scale of about 50 megaparsec. Again, millions of light years, unimaginably vast. We're talking really about moving galaxy clusters. And if we just want to send out probes or colonization ships or robots to do something, we can do that on a scale of about 4.7 billion parsecs. These are these big green spheres that we could touch, affect, settle, and change in the course of, even if it's just seeding life on planet. These are enormous scales, and you might notice that it's actually bigger in many ways than the structure of the universe. It might be that we have a bubble distance where different civilizations show up at different points in time. Maybe life is very rare. So you have the distances. Sometimes we might meet aliens, but it might be that the universe is really lonely. But the important thing is the cosmological structure on the vaster scales might be better described by looking at what intelligence is doing in the long run than just talking about what the galaxies are. So my friend and colleague Guy Kahane, a philosopher, wrote a brilliant and very darkly funny paper on our cosmic insignificance. And he asks, is the idea supposed to be that to be cosmically significant, we need to be moving galaxies around? He meant it ironical, and I think there is some truth to it. Because his definition of being significant is when you describe a situation, leaving out that thing that is significant means that the description misses something important for understanding it. And I do think intelligent life looks like it could be significant for actually describing the future structure of the entire universe. Maybe we're one in the crowd of the super civilizations in the long run. Maybe we are not the most significant one. But I do think we do matter. And the interesting thing is, we might choose what structure is. We might actually decide that this is stupid. Let's stay on Earth and play World of Warcraft or watch soap operas. Maybe we say, yeah, we should be tending nature in a static way. Or maybe we only need to settle the Milky Way. The rest of it is too far away or against our religious views. It's all dependent on what we or our descendants choose. This is actually a choice. It's not set by the laws of physics. So that leads to this question, what does this actually mean for us now? And I'm arguing that the future is potentially absurdly, tremendously, astronomically big, bright, and grand. There could be so much value, so many lives. And indeed, this means that we have a lot of responsibility because we're sitting here right near at the start of history. And if we are flubbing it right now, there might not be this enormous future. Indeed, we might really need to focus a lot on reducing the risks to our future, make sure that we have options and that our descendants do not run out of options. If we delay settling the universe, we might lose entire galaxies per year because they're disappearing because of expansion. But on the other hand, if we take too much risk, we might wipe ourselves out when we're still on one planet. We cannot hope to have an archipel in every crisis, although individually we should hope to have that kind of backbone. I think we all should resolve to, if we have that chance to not destroy the world, we should definitely take it. I also think that we need to recognize that what I've been outlining is possibility. It's not probability. But the one fascinating thing about intelligence is that we are nudging things in the world by moving matter around, by building computers, by telling each other things to make unlikely things more likely. That is what intelligence is. It is manipulating the world to make it more like we want it to. And if we see the grandiose possibility that we really want, or we want to just safeguard ourselves against threats to our values, we can use our intelligence to do that. We can use this to actually survive really well, really long, and reach an amazingly grand future. And this should be a reason to get out in the bed in the morning and say, okay, today is the first day in the rest of the history of the universe. Thank you.
Thank you so much. And to our audience, please stay tuned and join our next panel on space, transportation, and logistics. We'll see you in a few moments.